Good morning, student. Now I am going to discuss about a new chapter, that is your redox reaction. There are different types of reaction, such as number one is your displacement reaction, decomposition reaction, addition reaction, polymerization reaction, redox reactions. Among all these reactions, now I am going to discuss about the redox reaction. What is the meaning of redox reaction? Actually, the redox reaction generally belongs to two reactions. One is your reduction, another is your oxidation. When both reduction and oxidation reaction takes place simultaneously, then it is called redox reaction. Most of the biochemical reaction are redox reaction. Redox reactions are generally found in batteries, burnings of fuel, extraction of metals, corrosion of metals, digestion of foods, etc. generally belongs to the redox reaction. Then I am going to discuss about what is the reduction reaction and what is the oxidation reaction. There are generally two types of concept to define the definition of reduction and oxidation reaction. At first I want to discuss about the classical concept for the reduction and oxidation reaction. Also there is another concept for the reduction and oxidation reaction, that is said to be electronic concept. One is your classical concept, second is your electronic concept. According to classical concept, what is the definition of oxidation? According to classical concept, oxidation reaction are the reaction in which addition of oxygen or removal of hydrogen takes place. Then such type of reactions are generally said to be oxidation reaction. For example, carbon react with the oxygen gives the carbon dioxide. Look at that, here oxygen is added with the carbon to form the carbon dioxide. So this is an oxidation reaction. Like that, take another example, H2S plus Cl2 gives the 2HCl plus sulfur. Here hydrogen atom is removed, so this type of reaction is also called oxidation reaction. On the other hand, if I want to think about the definition of reduction reaction according to classical concept, the addition of hydrogen or removal of oxygen is called reduction reaction. Let me explain the definition of reduction reaction with the example. Fe2O3 plus 3CO gives 2Fe plus 3CO2. Look at that, here removal of oxygen takes place. So this reaction is also called reduction reaction. Take another example, F2 plus H2 gives 2HL. Look at that, here hydrogen atom is added. So this type of reaction is also called reduction reaction. Next I want to explain about the electronic concept. According to electronic concept, what is the oxidation reaction and what is the reduction reaction? Oxidation reaction is a process which involves loss of electron. On the other hand, reduction reaction is a process which involves gain of electron. In oxidation reaction, what happens? Generally, the oxidation number goes on increases. On the other hand, in reduction reaction, the oxidation number goes on decreases. Finally, we concluded that in oxidation reaction, loss of electron takes place. On the other hand, in reduction reaction, gain of electron takes place. Similarly, we can also conclude that in oxidation reaction, oxidation number increases, while in reduction reaction, oxidation number decreases. In oxidation reaction, due to loss of electron, there is an increase in positive charge or decrease in negative charge of the atom or ion undergoing oxidation. Let me explain with the example. Sodium gives a Na++ electron. Look at that. In this reaction, loss of electron takes place. So this is said to be an oxidation reaction. Take another example. MnO4 2- gives a MnO4- plus electron. Look at that. In this reaction, loss of electron takes place. So this reaction also belongs to oxidation reaction. But in this case, the positive charge goes on increases. Here the charge is 0, but here the charge is plus. So we think that there is an increase in the positive charge. That means this reaction belongs to the oxidation reaction. But in this case, what happens? The negative charge goes on decreases. Here 2- ion is present, here -1 is present. That means there is a decrease in the negative charge. That's why in case of oxidation reaction, the positive charge goes on increases, while the negative charge goes on decreases. Similarly, in case of reduction reaction, due to addition of electron, there is an increase in negative charge or decrease in positive charge. Take examples to explain these 2 points. Fe3+ electron gives a Fe2+. Similarly, take another example. MnO4- plus electron gives a MnO4 2-. Look at that. In these 2 reactions, addition of electron takes place. So these are the examples of reduction reaction. Remember an important point: the substance which helps to reduction reaction is called reducing agent. On the other hand, the substance which helps to oxidation reaction is called oxidizing agent, or it is also called oxidant. On the other hand, reducing agent is also called reductant. Next, I want to explain about the oxidation number. What is the meaning of oxidation number? The oxidation number of an atom in a compound is the number of electrons which appeared to have lost or gained during the formation of that compounds. Next point, oxidation number is positive or negative or zero or fraction. Oxidation number is not a real charge. Oxidation number not a real charge in case of covalent species. Next, I want to explain about the rules for the calculation of oxidation number. What are the rules for the calculation of oxidation number? First rule is the oxidation number of a substance in its elementary state is equal to 0. Take example H2, N2, O2, F2, potassium, calcium, magnesium, etc. having zero oxidation state in the elementary state. Next rule, the algebraic sum of oxidation number of all the elements in a molecule is equal to 0, and for an ion it is equal to the charge of the ions. Let me explain this rule with an example. Suppose I will think about the oxidation state of each element present in KMnO4 molecule. According to this rule, I can write here oxidation number of potassium plus oxidation number of manganese plus 4 into oxidation number of oxygen equal to 0. According to this rule, the sum of oxidation number of all the elements in the molecule is equal to 0. In case of ion, I can write here also. Suppose take an example NH4 plus. For this ion, I can write oxidation number of nitrogen plus 4 into oxidation number of hydrogen equal to plus 1. Similarly, I can also take another example. In case of CO3 2- ion, I can write oxidation number of carbon plus 3 into oxidation number of oxygen equal to -2. Similarly, you can also write for K2Cr2O7 2 into oxidation number of potassium plus 2 into oxidation number of chromium plus 7 into oxidation number of oxygen equal to 0. From this example, it is clear that for molecule we can think about the value 0, and for ion we can think about the charge on the ion. Next rule, the oxidation number of monoatomic ion is equal to the charge on the ion. For example, oxidation number of Na plus equal to +1. Similarly, oxidation number of Ca2 plus equal to +2. We can also write another example, oxidation number of Cl minus ion equal to -1. That means the oxidation number of a monoatomic ion is equal to the charge on the ion. Next rule, except hydride compound, the oxidation number of hydrogen in all compounds number of hydrogen is -1. Take example, sodium hydrate. Here the oxidation number of sodium is +1. So it is bound to think that the oxidation number of hydrogen is -1. Similarly, think about magnesium hydrate. Here the oxidation number of magnesium is +2. From this it is clear that here the oxidation number of hydrogen is -1. Take another example, H2O. Here the oxidation number of oxygen is -2. From this value it is clear that here the oxidation number of hydrogen is +1. Next rule, oxidation number of oxygen generally taken as -2, but in case of some compound its oxidation number may be changes. That means its oxidation number may be -1, +2, +1, -half, like this. In case of water the oxidation number of oxygen is -2. But in case of H2O2, the oxidation number of oxygen is -1. In case of OF2, the oxidation number of oxygen is +2. In case of O2F2, the oxidation number of oxygen is +1. In case of KO2, RbO2, CSO2, the oxidation number of oxygen is -1/2. Next rule, the oxidation number of alkali metal like lithium, sodium, potassium, rubidium, cesium, francium having +1 oxidation number. Similarly, think about the alkaline earth metal. The oxidation number of alkaline earth metal, that is your beryllium, magnesium, calcium, barium, strontium having +2 oxidation state. That means see the oxidation number of alkaline earth metal is +2. On the other hand, the oxidation number of alkali metal is +1. Generally, the oxidation number of halogen elements, that is fluorine, chlorine, bromine, iodine, is -1. But in some cases the oxidation number of halogen atom may changes. But remember, fluorine always having -1 oxidation number. Other halogen element like your chlorine, bromine, iodine may changes its oxidation number like +1, +3, +5, +7. Take example, in HClO the oxidation number of chlorine is +1. In HClO2 the oxidation number of chlorine is +3. In HClO3 the oxidation number of chlorine is +5. Similarly, in HClO4 the oxidation number of chlorine is +7. Next rule, in binary compound of metal and non-metal, the oxidation number of metal is always positive, while the oxidation number of non-metal is always negative. Take an example, in NaCl, sodium is a metal, chlorine is a non-metal, so the oxidation number of sodium must be your positive. On the other hand, the oxidation number of chlorine must be negative. In NaCl, sodium having plus 1 oxidation state. On the other hand, chlorine having minus 1 oxidation state. Similarly, take another example, MgCl2. In MgCl2, magnesium having plus 2 oxidation state, while chlorine having minus 1 oxidation state. Magnesium belongs to metal, so its oxidation number is positive. On the other hand, chlorine belongs to non-metal, so its oxidation number is negative. Next rule, if the binary compound formed by the combination of non-metallic atoms, then the atom with a higher electronegativity value having negative oxidation number. On the other hand, the atom, that means the non-metals which having lower electronegativity value having positive oxidation number. Take an example. In case of HCl, both hydrogen and chlorine belongs to non-metal, but the electronegativity of chlorine is more than hydrogen. So chlorine shows negative oxidation number while hydrogen shows positive oxidation number. These are some rules by which we can able to find out the oxidation number of an element in a molecule or ion. Let us take some example for the calculation of oxidation number. Suppose I will think about an question. Find the oxidation number of iron in number 1 is your FeO, number 2 is your Fe2O3. Now I will think about FeO. FeO is a molecule. In case of molecule, the oxidation number is 0. In our question, find out the oxidation number of iron. Suppose the oxidation number of iron is your X. Here one iron atom is present, so here I can write 1 into X plus oxidation number of oxygen, that means I can write here minus 2 into 1 because the oxidation number of oxygen is minus 2. Here only one oxygen atom present, so here I can write 1. For this molecule, I can write oxidation number of iron plus oxidation number of oxygen equal to 0. Here one iron atom is present, so here I can write 1 into oxidation number of iron plus here one oxygen atom is present, so here I can write 1 into oxidation number of oxygen, which is equal to 0. In FeO, the oxidation number of iron is suppose taken as X. So here I can write 1 into X plus minus 2 into 1 because the oxidation number of oxygen is minus 2. This term is equal to 0. Imply that here I can write X minus 2 equal to 0. Imply that X is equal to plus 2. Here X is the oxidation number of iron, so I can write the oxidation number of iron equal to plus 2. Now think about this molecule. For this molecule I can write 2 into oxidation number of iron plus 3 into oxidation number of oxygen equal to 0. Let the oxidation number of iron equal to X. So here I can write 2 into X plus 3 into oxidation number of oxygen is minus 2. So here I can write minus 2 which is equal to 0. That means I can write here 2x minus 6 equal to 0. Imply that 2x equal to plus 6, imply that X is equal to plus 6 divided by 2, which is equal to plus 3. Here X is the oxidation number of iron, so we can write here oxidation number of iron in Fe2O3 equal to plus 3. Next I want to do another question. Find the oxidation number of sulfur in SO4 2 minus iron. For SO4 2 minus iron I can write 1 into oxidation number of sulfur plus 4 into oxidation number of oxygen equal to minus 2. Let the oxidation number of sulfur equal to X. Now I can write here 1 into X plus 4 into oxidation number of oxygen means minus 2. So here I can write minus 2 equal to minus 2. That means here I can write X minus 8 equal to minus 2. Imply that X is equal to minus 2 plus 8. Imply that X is equal to plus 6. In our question, find out the oxidation number of sulfur. So here I can write oxidation number of sulfur in SO4 2 minus iron equal to plus 6. Now I want to do another question. Find the oxidation number of nitrogen in NH4 plus ion. Let the oxidation number of nitrogen equal to X. For this ion I can write 1 into oxidation number of nitrogen plus 4 into oxidation number of hydrogen equal to plus 1. Imply that I can write 1 into X plus 4 into oxidation number of hydrogen means plus 1. So here I can write plus 1. Here I can write equal sign. Then I can write here plus 1. Imply that I can write X plus 4 equal to plus 1. Imply that X is equal to plus 1 minus 4. Imply that X is equal to minus 3. In our question, find out the oxidation number of nitrogen. So here I can write oxidation number of nitrogen in NH4 plus equal to minus 3. Next I want to explain why redox reactions are electron transfer reaction. Electron transfer reaction. How can I explain why redox reactions are said to be electron transfer reaction? To explain this, take an example. Mg plus O2 gives the MgO. This is an example of redox reaction. That means here both reduction and oxidation reaction takes place. Look at that. The oxidation state of magnesium is 0 because magnesium present in the elementary state. So the oxidation state of magnesium is 0. But in this case magnesium having oxidation state plus 2 because here magnesium is present in molecule like your magnesium oxide. Here oxygen having minus 2 oxidation state. So the oxidation number of magnesium is your plus 2. Similarly here oxygen having also oxidation number 0. Look at that, here the oxidation number of magnesium changes from 0 to plus 2. That means there is an increase in the oxidation number. So here I can think that magnesium undergoes oxidation because here magnesium loses 2 electron and it converted into Mg plus 2 ion. Like that, look at here oxygen having 0 oxidation state but here oxygen having minus 2 oxidation state. That means there is a decrease in oxidation number. We know that increase in oxidation number is said to be oxidation, decrease in oxidation number is said to be reduction. That means we can think that your oxygen undergoes reduction. As a result, the oxygen converted into O minus 2 ion. In this reaction, both oxidation and reduction reaction takes place. So this is an example of redox reaction. This is an example of electron transfer reaction because in this reaction, 2 electrons transformed from magnesium to oxygen. As a result, magnesium converted into Mg plus 2 ion. On the other hand, oxygen converted into O minus 2 ion. Here magnesium loses 2 electron and these 2 electron gained by the oxygen atom. So this is an example of electron transfer reaction. In this reaction also oxidation and reduction reaction takes place. So this is also called redox reaction. From this it is clear that all the redox reactions are said to be electron transfer reaction. In this reaction, oxygen helps to the magnesium for the oxidation reaction. So here oxygen is said to be an oxidizing agent. That is also said to be oxidant. On the other hand, magnesium also helps to the oxygen for the reduction. So here magnesium is said to be reducing agent. It is also called reductant. Next I want to explain about different types of redox reaction. There are different types of redox reaction. At first I want to explain about the synthesis reaction. When a new substance is formed by the union of simple substance, then the reaction is called synthesis reaction. Take an example, Mg plus O2 gives a MgO. Here a new substance MgO is formed from the simple substance, that is your Mg and oxygen. So this is an example of synthesis reaction. It is also proved that this is an example of redox reaction. Both it is a redox reaction and also it belongs to synthesis reaction. Next type of redox reaction is analysis or decomposition reaction. When a compound split into its constituent or simpler substance, then the reaction is called decomposition reaction. Take an example, 2HgO gives a Hg plus O2. This is an example of decomposition reaction. Also this reaction belongs to redox reaction. Here the oxidation number of mercury is +2. Here the oxidation number of oxygen is -2. Here the oxidation number of mercury is 0. Here the oxidation number of oxygen is also 0. In this reaction, Hg plus 2 undergoes reduction and form Hg. On the other hand, here O minus 2 undergoes oxidation to form oxygen atom. So this is an example of redox reaction. In this reaction also a compound, that is HgO, undergoes dissociation, gives two simpler substances. One is your mercury, another is your oxygen. So this reaction also belongs to decomposition reaction. Next reaction is your substitution reaction. When one element displaces to other element from its compound, then the reaction is called substitution reaction. Take an example, zinc plus H2SO4 gives ZnSO4 plus H2. Here zinc displaces the hydrogen from H2SO4 compound, so it is an example of substitution reaction. Here the oxidation number of zinc is 0. Here the oxidation number of hydrogen is +1. Here the oxidation number of zinc is +2. Here the oxidation number of hydrogen is 0. In this reaction, zinc undergoes oxidation and gives Zn +2. Here H plus undergoes reduction to give hydrogen. In this reaction, both oxidation and reduction reaction takes place. So this is an example of also redox reaction. Next reaction is your auto redox reaction. This reaction is also called auto oxidation reduction reaction. This reaction is also called decomposition reaction. This type of reaction involves an element in one oxidation state which simultaneously oxidized and reduced. Take an example, 2H2O2 gives 2H2O plus O2. Look at that, here the oxidation number of hydrogen is +1, here the oxidation number of oxygen is -1, here the oxidation number of oxygen is -2, here the oxidation number of oxygen is 0. Look at that, here the oxygen atom undergoes both oxidation and reduction reaction, because one oxygen atom having -1 oxidation state undergoes oxidation and converted into oxygen atom. On the other hand, another oxygen atom having -1 oxidation state undergoes reduction and converted into O-2 ion. In this reaction, one element undergoes oxidation reaction and simultaneously also undergoes reduction reaction. So this is also said to be an auto redox reaction. Because in this reaction, one oxygen atom is used for the reduction of another oxygen atom. In this reaction, the two oxygen atom helps to each other, so it is said to be an auto redox reaction. This is all about for this class.